Ladies and gentlemen, distinguished guests, ladies and gentlemen, firstly, it's terrific to be back and wearing something a little bit more aerodynamically pleasant, and thank you very much for entertaining yourselves while we achieved our purpose. I'd firstly like to, if I may, welcome the Consul General of India. You do us great dignity and service for coming here tonight, and we thank you very much for being here. I'd also, if I may, like to particularly welcome Dr. Neville Roche. This speech, the links that we've had with India would not happen without a man of his standing, and I've watched him over so many years contribute so much to Australian-Indian relations and also the relationships of this university. And Dr. Roche, we thank you very much. Ladies and gentlemen, we're here tonight for the Wallace Wurth Lecture, another in a wonderful series that has gone for many, many years. Many of you may know that it commemorates the memory of the late Wallace Charles Wurth, who was the first president of the Council of the New South Wales University of Technology, and when we became a university, he became the first Chancellor. It is a great delight as I look down to see that we have here tonight some of his grandchildren and also, I understand, his great-grandchildren. So welcome to you, and let's hope that you always enjoy particularly passing by the Wallace Wurth building, which is just over there, and which, so the Vice-Chancellor tells me, is about to be upgraded to the standard of your grandfather and great-grandfather. This lecture series has run since 1964, the first lecture being given by the then Prime Minister of Australia, the Right Honourable Sir Robert Menzies. Since that time, it's covered all sorts of issues of current importance: ethics, justice, education, peace, post-communist Europe, university teaching, and research. I've been given a list of all the people who have given lectures here, and let me not quote them all, but I note the Dalai Lama, Jerry Adams, Jose Ramos Horta, James Wolfenson, Noam Chomsky, all names that are not only known, but they make me feel quite old because I think I've been to most of the lectures. But tonight, with great joy, we are here to hear Dr. Pachauri, I might say the latest graduate of this university, who will address us on the subject of our vulnerable Earth, climate change, the IPCC, and the role of Generation Green. As I mentioned earlier, this university wants deliberately to be involved in helping in climate change, whether it be educating, researching, or just setting an example. And in the middle of your booklet, and please note it's not a separate piece of paper, we're not contributing to litter, you will see a plug for our Generation Green campaign, a campaign we're very proud of, and we would be delighted if you want to know more about it when you've read that piece of paper. You'll be pleased to hear, particularly if you're getting bored of hearing from me, that I don't intend to say anything further about Dr. Pachauri. You heard from the Vice-Chancellor, you know of his enormous achievements, and you know that here's a man who's making a difference. I'm absolutely delighted, as is the entire university, that he's agreed to address us tonight, and I really welcome him to the stage to do so.
Chancellor, Mr. Vice-Chancellor, Consul General of India, Mr. Neville Roche, distinguished ladies and gentlemen, colleagues from this remarkable institution. It's indeed a great privilege for me to be given this opportunity to deliver the Wallace Wurth Memorial Lecture. And I didn't know that I'm the first graduate who's doing so. I suppose I've set a pattern. Next time you have someone getting a bachelor's degree, they would feel daunted at the prospect of standing here and delivering this lecture. But I'm really grateful for this honor, and I feel particularly humbled at the names that you read out, Chancellor, of people who really tower above everybody on this in the human race, and I feel I'm being honored unduly by being given this opportunity. I'm basically going to talk about climate change, what the IPCC is, what its role has been, and more importantly, on what the role of Generation Green should be in this whole range of complex issues that I'm going to try and present before you. And most of what I would show you by way of scientific facts and findings are based on the fourth assessment report of the IPCC, which, as you probably all know, was released last year in 4 different parts. And the way the IPCC functions is there are 3 working group reports dealing with the physical science basis, the impacts, adaptation and vulnerability, that's the second one, and the third one deals with mitigation issues. And finally, we bring out something called the synthesis report, which essentially synthesizes the material and the findings that are presented in the 3 working group reports. So let me move on. I'd like to first take you back in time. It's not as though the science of climate change is something that's just dawned on us suddenly. It's something that's been known for a long period of time. And there were several scientists, even ahead of the one that's listed over here, that's Arrhenius, a Swedish scientist, who really came out with this remarkable and path-breaking theory that burning of coal and adding to the carbon dioxide concentration of the atmosphere would lead to warming. And you can imagine this was an extremely difficult task because he had to solve literally hundreds of equations, all manually, to come up with this kind of finding. Then, of course, 1988 turned out to be an extremely warm year in North America and several other parts of the world, with also a prolonged drought. And this was the year when the Congress of the United States got very concerned at what they were witnessing. And they therefore called for material to be provided and testimony to be given in the House and the Senate on the scientific realities of climate change. And James Hansen, a NASA scientist who's still extremely active and keeps jogging everybody's knowledge with questions that he keeps raising and an extensive amount of material that he keeps producing. Well, he testified, and Congress, and then this also went to the United Nations, realized that we really needed a professional and scientific body to give us the facts of what climate change is all about. And that's when the IPCC was established by a resolution of the General Assembly of the UN. But I must say, in retrospect, the manner in which the IPCC was established was in some sense a stroke of genius. It was established by the UN, but it's not part of the UN in the strict sense. It's an intergovernmental body, and therefore all the decisions are taken by all the governments of the world, since they happen to be the members of the IPCC. And in 1992, based on largely on the first assessment report of the IPCC, the UN Framework Convention came into existence, which essentially provided a framework of how we might be able to deal with the problem of climate change. Then in 1997, after a great deal of deliberation and negotiations, the world came up with the Kyoto Protocol, which essentially involved cuts in emissions by most developed countries, the industrial nations. Australia, of course, was allowed a certain increase on account of its very special characteristics. And I'm afraid it took a long time for the Kyoto Protocol to be ratified. And at that stage, 2 major countries didn't ratify it, the US and Australia. And finally, what tilted the balance was Russia ratifying it, because that completed the total number of countries that were required to ratify the Kyoto Protocol and accounted for the requisite percentage of emissions that they would be responsible for in ensuring ratification. So it's been a tough journey, and I wanted to emphasize that. And now, of course, the IPCC is 20 years old, and I'd like to get on with what we've been able to do. Well, firstly, the role of the IPCC is to carry out an assessment of all aspects of climate change, scientific, technical, and socio-economic. And we've brought out 4 assessment reports. The 4th, as I mentioned, was completed last year. It's important to understand the manner in which the IPCC functions. We function on a very transparent basis. The process that's followed once an assessment cycle is begun is for every draft of the report to be reviewed carefully. And the very first draft is reviewed by expert reviewers, and a number of comments are provided. Each one of them is very carefully logged, and we have to record which ones are accepted, and the ones that are not accepted, we have to provide reasons for non-acceptance. Then finally, the government, well, the second draft is reviewed by governments and experts, and the draft summary for policymakers, incidentally, has to be accepted word by word. And this is something which I might mention in the media and in the minds of some of the skeptics is referred to as politicization of science. Because if the reports are accepted word by governments, and of course changes do take place in the process of approval, they say science is being politicized. But I'd like to clarify that actually, and I can say this quite objectively, in several cases we find governments are actually able to improve the language without in any way changing the content or the intent of what is stated over there. And this happens because, you know, scientists, all said and done, are not always the best communicators, particularly when it comes to providing messages that the public would understand, that policymakers would understand. So when policymakers themselves sit down over there and go through everything word by word, often they come up with very clear changes or suggestions for changes which actually improve the communicability of the report. So this is just to elaborate on the process that's followed, and the size of the effort can be gauged by what was involved in the 4th assessment report. We had 450 lead authors, and these are the people who actually write the report. But over and above that, we have a category called contributing authors. These are people who may be very specialized in a particular field, and they are asked to provide inputs to the lead authors. It could be, let's say, something like how acidification might affect coral reefs in a particular part of the world. And someone may have done a lot of research and knows everything about it, so he's asked to prepare an input. And that's used by the lead authors in structuring their own report. Overall, there were about 2,500 plus scientific experts who reviewed the 4th assessment report, and all of these were drawn from about 130 countries. We make a conscious effort to see that the authors and all those involved in this process are geographically balanced. And there are 2 reasons for that. Firstly, I think it's important for the IPCC as an intergovernmental body to ensure that we have full participation by experts and scientists from all over the world. And secondly, very often you need very specific regional information, insights, and knowledge about, let's say, the impacts of climate change. And unless you draw on the scientific community in a particular country or even part of a country, you really won't get the full benefits of the knowledge that exists over there. So this is a fairly elaborate and comprehensive process. Now let me highlight some key messages that have come out of the 4th assessment report. One of them, which I think is very eloquently stated, warming of the climate system is unequivocal. Now, this is something that really should be accepted as putting an end to any scientific doubt on the issue, which is not to say that people will not keep questioning whatever knowledge we create. It's in the nature of human behavior to doubt and question things that come out, and there'll always be a certain section of society that will not accept whatever is produced. If you look at the history of knowledge, you go back even to the time of Isaac Newton, people doubted whatever he came up with, and they wrote vehemently against his findings. And this has happened with every area of knowledge. So this doesn't in any way cause any anguish on our part, but it's something that we find is certainly being reduced in terms of the number of people who now doubt and question the reality of at least human-induced climate change. I'll just give you this diagram, which gives you data and observations in global average surface temperature going back to the beginning of industrialization. And you notice that there are ups and downs in this set of observations. And that's essentially because we are dealing with a number of natural factors that bring about changes in the climate. The climate has changed over the ages, and there are a whole range of natural factors, solar activity, volcanic activity, and so on, that can bring about changes in climate. But what you also would observe from this diagram is that in recent decades, this graph has become much steeper. And therefore, if you draw a line through the last 100 years of observations, you will get something like this as a fit, which gives you a total increase in 100 years of 0.74 degrees Celsius. This is the increase that you might say took place in the 20th century. However, if you look at the last 50 years, then you get a line which is much steeper, which is almost twice as steep as the total 100-year period. So it would be appropriate to conclude that we are now at a stage where warming is taking place much faster. And if we want further evidence of this, we know that 11 of the last 12 years rank among the 12 warmest years since instrumental records of global surface temperatures have been maintained. So I'd like to emphasize the fact that we're at a stage where warming is taking place at a much faster rate. And clearly, if we don't bring about some changes, we would have much faster changes in the future. And it's not as though climate change is a smooth, steady, and linear process. It's accompanied by a whole range of other effects that clearly have a major impact on human life and life of all kinds on this planet. Here we see the cumulative balance of glacier mass. And you would observe that except for 2 regions in the world, in every other region over the last 50-odd years, we have had a fairly sharp decline in the size of the glaciers, which in some parts of the world has very serious implications. Coming from where I do on the subcontinent, in the northern part, most of the river systems originate in the glaciers that are in the high mountains. And there is the prospect that with depletion of this mass, we would get much reduced flows of water through those river systems. And this, in our estimate, can affect the lives of about 500 million people spread across the entire northern part of the subcontinent. May I also emphasize that, it's not merely the water that flows in the river that is of concern, but the fact that with the reduced flow in the river systems, the water recharge in the groundwater system will also be reduced as a result. And that has a much wider effect than purely the areas under the rivers themselves. As a result of the melting of bodies of ice and also the thermal expansion of the oceans, sea level rise is proceeding at a much faster pace now than has been the case in earlier decades. And the total increase in the sea level in the last century has been about 17 centimeters on the average. But here again, if you look at the rate, since 61, the average rate was 1.8 millimeters per year, and since 93, it's increased to about 3.1 millimeters per year. The Arctic temperature has increased at almost twice the global average rate in the past 100 years, and therefore the average Arctic sea ice extent has shrunk by 2.7% per decade. And this is something that you really need to go there to observe. I've been to the Arctic region, and more recently, about 2 months ago, I also went to Greenland. And quite apart from all the scientific measurements that we have, today there is palpable evidence which is so visible that you can see it all over, particularly in the Arctic region, the sea ice that you see in the Arctic region. And therefore, this not only has implications for reduction in the extent of ice that's floating on the oceans and the increase in temperature that's taking place, but it also has serious implications for biodiversity and the species that are native to that region. Heat waves have become more frequent over most land areas. And as an example, I might mention the heat wave that took place in Europe in 2003, where 35,000 deaths took place. And this is not confined only to Europe. Heat waves have become common throughout the world. I'm sure data on Australia and parts of Australia would also indicate a similar trend. We also know that the proportion of tropical cyclones reaching higher intensity have increased over the past 3 decades. And this, I'm not necessarily saying what happened in Myanmar a few months ago, 5 months ago, was the result of human-induced climate change. But what we see is typical of the kind of trend that we find all over with tropical cyclones. Now, here I'd like to emphasize one important point. Climate change has a major impact in terms of exacerbation of existing stresses. Cyclones have taken place all along, will always take place in the future as well. But today, a cyclone becomes much worse in terms of its impacts simply because sea level is much higher than was the case earlier. Typically, if one was to look at what happened in Myanmar, this is a country which has a large continental shelf, and when a cyclone hits that area, it picks up all the water from the continental shelf and carries it on shore and causes devastation. Now, in the case of Myanmar, given the fact that sea level is much higher today, you can imagine the quantity of water on the continental shelf is substantially larger than would have been the case earlier. Now, here, let me give you another example, which of course has nothing to do with climate change. The tsunami that took place over 4 years ago. If sea levels had been a bit lower, the extent of devastation would have been substantially lower. And often people ask me, isn't tsunami caused by climate change? You know, today there are some people who link everything with climate change, and that I think is dangerous. It's important for the scientific community to dispel any such feelings. One could say that the Australian team losing in India was the result of climate change. But I assure you, I had nothing to do with it. So you'll have to check with Ricky Ponting. There are more intense and longer droughts that have been observed over wider areas since the 1970s. And about 25% of Africa's population is in any case living under high water stress. But this, over a period of time, will get much worse. The frequency of heavy precipitation events has increased over most land areas. We had a terrible incident in Mumbai in 2005 where about 1 million people lost their homes. And actually, some people lost their lives simply because they were stuck in the traffic. The water was 4 or 5 feet high in some cases, and the whole city was paralyzed. And a few people actually suffocated in their cars because they couldn't roll down their windows, they couldn't open the doors, and they just sat there for several hours, and a few of them actually lost their lives. So here may I emphasize that the increase in frequency and intensity of some of these events requires that we adapt to this reality for the future by taking a whole range of specific measures. In this specific case, in the case of Mumbai, for instance, perhaps, and that's true of several other cities in the world, we need to revamp our drainage system, because a drainage system which was designed for a terrible event of this kind once in 50 years may now have to deal with such events once in 7 or 8 years. So that clearly changes the whole perspective of risk management, and you would need to engineer some of the infrastructure that's required with this in mind. Now, if we look at the prospects for the 21st century, we know that continued greenhouse gas emissions will certainly induce many changes in the global climate system, and these would most likely be much larger than those observed during the 20th century. So we now have enough reason to believe that unless we do something about this problem, the situation is certainly going to worsen over a period of time. And based on the scenarios that we have developed in the IPCC, which are all plausible scenarios of the way the economies of different parts of the world, technological changes, other socio-economic changes that will take place are likely to develop, we have come up with projections of temperature increase which range from 1.1 to 6.4 degrees by the end of the century. Now, even at the lower end of this range, we have reason to be concerned with the value that's shown over here, because remember, during the 20th century, there was an increase of 0.74 degrees. If you add that to 1.1 degrees Celsius, you get a temperature increase of about 2 degrees or so, and a lot of inertia in the system which will carry it even beyond that. What are the expected impacts on Australia? Well, water security problems by 2030 in southern and eastern Australia would intensify. Risks from sea level rise are quite obvious, and the frequency of storms and coastal flooding by 2050 would increase, and these will be exacerbated by ongoing coastal development and population growth. So therefore, there is clearly a lesson in this for zoning policies and regulations. There'll be a significant loss of biodiversity by 2020 in some ecologically rich sites, including the Great Barrier Reef and the Queensland wet tropics. There's also expected to be a decline in production from agriculture and forestry. And I might say we in India are doing a fair amount of research on the impacts of climate change on agriculture. And the recent evidence seems to indicate a very high level of sensitivity of certain crops to temperature increases. Wheat in particular. As a matter of fact, in the case of wheat, even a 1 or 2 degree increase in temperature during a particular stage of the growth cycle can prove extremely harmful in terms of negative changes in the yields of the crop. We have several means by which human society has been able to cope with changes in some of these conditions. But the point I'd like to make is that we would find that with the changes that would take place in the future, our ability to be able to cope with some of these will be far exceeded. So the capacity that human society has of coping with issues like the threat to water security, coastal communities being threatened, and so on, is now reached a stage where further changes in climate and all the related variables would certainly be far beyond the capacity of these communities to be able to cope. So what we need, therefore, is an approach by which we mitigate the emissions of greenhouse gases. And just to add to the urgency of the problem and the fact that we need to avoid some of these terrible impacts, by 2020 there will be 120 to 1.2 billion people in Asia affected by water stress. In Africa, 75 to 250 million people, and possible declines in agriculture by 2020, and I think that's important. In some African countries, we would have a decline of about 50% in the yields of agriculture. If we do nothing, then crop revenues could fall by 90% by 2100 in Africa. So, you know, it's a continent that is threatened in a variety of ways, and it's a continent where you already have substantial stresses. If you look at what's happened in the last 6 or 7 months with increased food prices, those countries and those households which spend 80 to 90% of their incomes in merely buying food are completely devastated. They are no longer in a state whereby they can buy enough food to meet their nutritional needs. So that clearly is something that we need to be concerned about. And may I say, the fact that the Norwegian Nobel Committee decided to award the Peace Prize last year to the IPCC and Mr. Al Gore is a clear reflection of their assessment that if we don't do anything about climate change, peace and stability in different parts of the world could be disrupted. And we can see that happening simply because there'll be a great deal of competition for scarce resources like water, a great deal of implications arising out of malnutrition, hunger, and a complete breakdown in the food cycle. So all of these are clearly impacts of climate change that we should do everything to avoid. There are also some abrupt or irreversible impacts, like partial loss of ice sheets on polar land, and this refers particularly to the Greenland and the West Antarctic ice sheet. If these were to, any part of them was to collapse, then we would get major changes in coastlines and inundation of low-lying areas with sea level rise of several meters. We've assessed a number of species, and 20 to 30% of them are likely to be at risk of extinction if increases in warming exceed 1.5 to 2.5 degrees Celsius. And it's interesting to observe, of all the species on this planet, I think human beings need a whole range of species for their survival, whether it's medicines or food or several other activities. But I'm not too sure whether there are any species on this earth, except maybe pets that we keep in our homes, that require human society in any way for their survival. So, you know, we seem to have lost sight of the fact that we are part of a very fragile ecosystem in which our footprint and our actions are obviously causing much more damage than we can even conceptualize or imagine from any other species that might have an impact on us. Then there's also large-scale and persistent changes in the meridional overturning circulation, which is what you call the Gulf Stream. And that's also likely to have impacts on marine ecosystems. Now, what we have come up with as a major finding is that neither adaptation nor mitigation alone can avoid all climate change impacts. However, if they complement each other and together, they can significantly reduce the risks of climate change. So it's absolutely essential that we take in hand specific adaptation measures, because there is inertia in the system, as a result of which, even if we were to stabilize the Earth's, the concentration of greenhouse gases in the Earth's atmosphere at existing levels, climate change will continue, and therefore we will have no choice but to adapt. But on the other hand, we have to ensure that to minimize the impacts of climate change in the future, that we start reducing emissions of greenhouse gases as quickly as possible. And we therefore need a combination of both policies. Now, if we look at the role and limits of adaptation, I've mentioned this, societies have a long record of adapting, but of course climate change poses new risks, and therefore, excuse me, adaptation alone will not work. We'll really need to get into serious mitigation of emissions. Now, in the fourth assessment report, we've carried out a detailed assessment of means by which we could reduce emissions of greenhouse gases, stabilize the Earth's atmosphere, and thereby stabilize the temperature increase that would take place. The level that's generally been talked about essentially through the articulation of this goal by the EU is 2 to 2.4 degrees Celsius. If we want to limit temperature increase to this level, and this may not happen in this century, it may spill over to the next century or maybe even beyond, then all we have is a very short window of opportunity. We'll have to make sure that CO2 emissions peak by 2015 and decline rapidly thereafter. And the more rapidly they decline, the greater the possibility of our being able to avoid some of the worst impacts of climate change. Now, some people will tell you that such an approach will be extremely expensive in terms of loss of output and loss of jobs. But in actual fact, that's totally erroneous. The reality is that the cost of this kind of mitigation, and I'll say a little more on this, is really very little. If you look at this path of stabilization of the Earth's atmosphere, in 2030, at the most, it may cost the world about 3% of the global GDP. But in actual fact, it will be less. And if you want to visualize this 3% of the GDP, let's assume GDP growth would take place steadily without mitigation, which would give you this kind of a line. But if you carried out mitigation, you just rotate that line a little downwards. And what this means is that the level of prosperity that the world would have reached in 2030 will at best be postponed by a few months or at the most a year. And that's clearly not a high price to pay for avoiding all those impacts that would take place if we didn't take any action. Now, actually the situation is even better because there are huge co-benefits from mitigation. It might very well turn out that if we take these mitigation measures, rather than lose GDP, we might actually add to the GDP and add to human welfare. Because firstly, there would be reduced air pollution at the local level and therefore substantial health benefits. There would be increased energy security. I was reading something that Mr. Barack Obama stated about a week ago. He said he'd like to set a goal for the United States to eliminate imports of oil from the Middle East in the next 10 years. Now, he'll obviously have to move to other sources of energy if he wants to do that. He'll have to improve energy efficiency, all of which is essentially a set of measures for mitigating emissions of greenhouse gases. So there's a clear overlap between bringing about greater security of energy supply and reducing emissions of greenhouse gases. There would also be more rural employment. If you look at the case of Germany, which has followed a very proactive policy in promoting renewable sources of energy, they've not lost GDP. They haven't lost jobs. They've actually added jobs. And they've created a new industry, which is now a thriving part of the German economy. And this is true of several other countries in the world. So if, let's say, in the developing countries, we were to use some of these technologies once they become viable, then clearly it would generate rural employment on a large scale. And given the fact that the impacts of climate change on agriculture are likely to be negative in the aggregate, it's important that we mitigate emissions so that agricultural productivity will not suffer as a result of the impacts of climate change. So these co-benefits actually provide the opportunity for no regrets policies and would reduce mitigation costs. And they may reduce them, it may reduce them to the level where they actually become negative costs. That means you actually increase your GDP. So now there's urgent need for action, simply because, as I mentioned, there's inertia in the climate system. Even if we were to hold GHG concentrations constant, a further warming trend would continue for the next few decades. So we must in any case adapt. And there's also an energy system inertia. I mean, whether you look at automobiles, you look at homes, we have a certain amount of infrastructure which is hooked onto a certain type of energy consumption. And therefore you can't bring about radical changes. So the whole system contains a certain level of inertia which has to be taken into account in mounting mitigation actions. But therefore, we need to start early, because whatever we can do today, we must do today, because there would be roadblocks, there would be constraints in what we are able to do tomorrow. And the sooner we do it, the less the likelihood of further climate change that would be dangerous or harmful. Now, there's substantial potential for mitigation of greenhouse gas emissions, and therefore we need to reduce them over current levels as quickly as possible. The good news also is that in all the stabilization levels that we have assessed, we know that all the technologies that we need are available today. Or are about to be commercialized. So there's no reason to wait for action to be taken. That action can be taken in hand immediately. However, in the future, we would need new technologies, and these will develop only if we have the right incentives in place. And unfortunately, if you go back to the last 20-odd years, R&D expenditures have actually been going down for developing energy alternatives. Key mitigation instruments and policies would be regulations and standards, let's say regulation of energy use in buildings, taxes and charges, that means you need fiscal measures, appropriate energy infrastructure investments. Let's say if you're investing in a thermal power plant, the life of which is 40 years, we necessarily need to take into account the kind of regulatory barriers we might have 10 to 15 years from now, and therefore in anticipation, should we be investing in conventional technologies or something better than that? Research, development, and demonstration is absolutely critical, and what is extremely important is to place a price on carbon. If there's a price on carbon, then producers and consumers will have incentives to move to low carbon technologies. Now, what's the role of Generation Green? I think efforts from civil society are essential to influence policy making. And I think youngsters have a remarkable ability and power to influence decisions. When I'm in Delhi, which is very rare, I normally go for a swim, and I find, I used to find a person who also comes for a swim would stand in the shower next to me and keep showering for half an hour, and he'd keep singing. So I had to put up with both these annoyances, someone wasting water indiscriminately and singing as though he was a star. So anyway, that actually shortened my shower even more than it would have been the case. However, one fine day I discovered that this guy had changed his pattern completely. And I asked him what happened. And he said his son had read somewhere or the other that the ideal length of a shower is 7 minutes. So he says, every time I shower at home, he comes and knocks on my door and he says 7 minutes are up. So he's now maintaining the same discipline. One of these days when I run into his son, I'm going to thank him and maybe give him a few chocolates. So I think Generation Green can send signals to the market. We've seen how, for instance, the move towards using organic food has made such a difference, because consumer preferences have entered the market and have certainly influenced supply responses. Maybe something similar would work over here. We need to directly mitigate greenhouse gas emissions through changes in consumption behavior. Household end users contribute over 40% of US total carbon emissions. So I think we really need to change our behavior in the household. And education is a very powerful tool to shape Generation Green and ensure cultural changes that are needed. Recently, I gave 2 talks, one in Belgium, which was attended by about 650 people, and another one in London, which had about 450 people. The one in London was organized by a group called Compassion for Global Farming. And I talked about the need to consume less meat because the meat cycle, particularly the factory meat production that we have today, is highly intensive in emissions of greenhouse gases. So my appeal, after I gave them all the facts of the cycle, incidentally, the FAO has done a very detailed study on this. My appeal was to say, look, if you eat less meat, you'll be healthier and so would the planet. This got a lot of publicity, a lot of press coverage, but I was quite amused and surprised to see that the current mayor of London, Mr. Boris Johnson, wrote an op-ed page article in the Daily Telegraph in which he said, because Dr. Pachauri is recommending that we should eat much less meat, I'm actually going to go and gorge and eat much more. He says, I'm going to do nothing of the kind, and I see no reason why we should change our lifestyles. I actually got an email from somebody else who said, you've got a serious problem because you're not eating meat, and therefore you are undernourished, and that's affecting the functioning of your mind. Anyway, sometimes you have to take these hazards in your stride. I've given some numbers over here. 1 kilogram of beef is responsible for the equivalent of so and so. My purpose in bringing this whole thing up was to highlight the fact that we as human beings cannot expect governments, cannot expect somebody far away to act to solve this problem. As Mahatma Gandhi said, be the change you want to see in the world. If we really want to bring about change, I think we have to start doing that with our own lifestyles, which doesn't mean that we give up all the good things in life. But if we were to make adjustments, if we were to come up with technologies that can really provide solutions, then I think the pain of bringing about a transition would be much, much lower. Now, in this respect, I want to end by showing you a little video, 3 minutes, which deals with a very serious problem that we have in the world, and that of 1.6 billion people not having access to electricity. And since they don't have electricity, the kind of lighting devices that they have, if at all, are in the nature of a candle or a little oil lamp, which gives you pollution, gives you very inadequate light, and in essence, a miserable existence. Today, in my institute, we've developed solar lanterns and solar torches, which we are trying to promote on a large scale. And we've set our goal as lighting 1 billion lives. That means 1 billion households. And let's assume that there are 5 people in, not 1 billion households, 1 billion people. Let's assume there are 5 people per household. We're talking about 200 million households. And if we were to do that, the world was to do that, it'll cost between $15 to $20 billion. The cost of the Iraq war, $12 billion a month, I'm told. So I'll show you just this brief video about this program, and I want to illustrate that as a means by which we can bring about change by thinking out of the box. So could we have the video, please? thank you for this privilege. Thank you very much.
Well, that was a wonderful lecture, and certainly in the tradition of the great lecturers that have delivered this address. Dr. Pachauri has kindly agreed to take some questions. So if there are members of the audience who'd like to ask one or two questions, there will be people with roving microphones, and we will get them to you. So, oh, you got to grab it. Right, who? We had a gentleman down the centre.
I was briefly in doubt about global warming this morning when I nearly froze to death on my way to work. Are you afraid that your agenda might be overtaken by the consequences of peak oil and the current economic troubles in the world? With consequences, I mean, if we run out of oil, we use more coal. And with economic troubles, I mean, governments might be afraid to put a tax on carbon if the economy is in trouble.
Well, in my view, what's likely to happen is the current uncertainty and turmoil hopefully will end in the next couple of months or so, which doesn't mean that the problem will be solved, but at least one would see the contours of the solutions that would be required. And I think there'll be a great deal of churning at that point of time. And my feeling is that people are going to look at the very fundamentals of why we have these problems today. And at that stage, climate change will certainly be at the top of the list. I agree that in the current milieu, it's unlikely that people will take any harsh decisions, and this also strengthens the hands of the skeptics who don't want anything to be done. But I feel reasonably confident with the extent of awareness that there is and the desire to take action. Once we have a little more clarity on how this economic downturn is going to play out, addressing climate change will be an important part of the agenda.
Thank you. So, gentlemen.
Should we consider reduction of human reproduction as one of our weapons against the problem? Your own country now has the same population as the entire planet had in 1900. Why is this issue not looked at, since whatever else, if we have twice as many people, the problem is about twice as big?
Yeah, I always, when I get this question, I give the example of an event that we had organized in Washington where Senator Tim Wirth was one of the featured speakers, and the conference was on population, environment, and development. And he said, look, we have a population problem in this country. He says we add 3 million people to our population each year, and each American consumes 40 times as much as a Bangladeshi does. So we are adding 120 Bangladeshis to our population each year. You know, similarly, if you look at the case of India, yes, we have a very large population, but our emissions per capita are about 1.1 tons per capita as compared to the US. Having said so, we really have to find means by which we stabilize our population for our own reasons. As it happens in a democracy, it's not easy to bring about that kind of change. What really has a major impact is education of the girl child, the provision of basic services, And the government is trying to do that. One reason why we've had a major increase in population is because before independence, our life expectancy was less than 30 years. It's now more than doubled. So therefore, the reflection of this fact in people's fertility behavior has a certain lag built into it. And I'm not being apologetic about this. I think we certainly need much more vigorous ways by which we ensure that people's own decisions to limit families move us in that direction. And to be quite honest, we ought to be doing much more.
This is Vijay Singhal. I think to answer that question is more than people, the animals. They, in 1 year, some 57 billion animals are slaughtered. So on the planet, how many animals live? And if we start consuming more animals, that is adding to the global warming more than the people are doing.
Well, I don't have any numbers, so I wouldn't want to say anything in favor or against that point. Yeah.
We have down the back here. Yes, microphone.
Well, this is certainly happening. There's no question about it. I think what you really need are regulations in countries whereby we can ensure this kind of leakage doesn't happen. Now, in some countries, particularly mine, we have an active civil society, and also a very active media that I think limit this kind of that limit this kind of leakage. But there are
It's an Australian tradition to keep the speaker up here till they drop. It's a tradition that follows with countries that beat us in cricket. that put up slides saying global warming had nothing to do with the test loss, and then show you, he claimed it was agriculture, but I swear it was a photograph of the pitch with the worst cracks that I have ever seen. And,
well, what the Vice-Chancellor just said in the 1930s was called bodyline bowling.
But I think we'll make this the last question, because I think we really have had more than our fair share, and I think it is not an Australian tradition to take away the voice of a person who's only just got here and has to leave. I think it's wonderful to see, from the university's perspective, how much a person learns here when they get a degree so quickly. But I think we really have had a treat tonight. I think we've had a very erudite exposition, and we've also had a very sobering exposition. And many refer to this as a diabolical problem. The problem of climate is a diabolical problem, and yet Dr. Pachauri tells us that it isn't necessarily a win-lose problem. It could be a win-win problem. Then you say, if it's a win-win problem, why is it a diabolical problem? And it's the classic issue of all economic reform, and it's why I think a man with his background both of science and economics is uniquely qualified to lead this understanding. And that's because while in total it might be a win-win problem, when you get down to the level of the firm, as some of the questions indicated, there are some big losers. And so what we have is a few big losers and a lot of winners who can't really perceive the nature of the gain. And that's the classic question in economic reform. And it's why it's a diabolical problem. But it becomes less a problem when what is brought to bear is the kind of scholarship and leadership that we've been able to see tonight in the lecture. And for this, Dr. Pachauri, I thank you on behalf of all of us here at the university, and we are proud that you hold this honorary doctorate from us. If you would join me in thanking again Dr. Pachauri. And we do have a small gift which, if you do want to travel light, we will mail. But once again, thank you.
Thank you. Thank you. Thank you very much. Thank you very much. All I want to say in response to the Vice-Chancellor's remark about my quick learning soon after having got this degree. I come from a society where the credit is always given rightly to the guru. So he gets the credit for my quick learning. Thank you very much. Thank you.